when things go wrong, it's always like 4 a.m. on a Saturday. And these last two stages were super tight. And should we drop some sand we're trying to put in there? Should we add more perforations? And it's like, it's 4 a.m. on a Saturday. And the thing is, it's like, well, I don't know if I make that change, what is the impact going to be to just the cost and time? But we went through this whole process and optimized this design because it hit the hurdle rates we needed for IRR, and it was the one that maximized the most 2-year free cash flow, let's say. Mm-hmm. If I make this change, like, am I jeopardizing that? Am I not jeopardizing that? And that's where,
cycle.
You could do a quick simulation in PrePad and understand, what's going to be the impact? Call, let's say, the boss or somebody else and get the blessing to go forward with it and just have the information.
Yeah, and the ability to move that real-time data back to you guys so that you can kind of have the data required to rerun that simulation in real time. I think like that's the ultimate, that's kind of the wet dream.
Yeah, exactly.
Right? On today's episode of Nerdin Out, we're tackling some of the biggest shifts in energy right now. Data centers are surging, the grid is straining, and North American LNG is stepping into the spotlight. Additionally, we'll talk about how simul-frac is becoming standard practice in today's landscape. We're breaking down what this means for the future of energy. So joining us today is Sean Hervo, co-founder and CEO of PrePad. Sean spent nearly 15 years in the oil and gas industry, blending engineering expertise with business strategy, and he's leading a company that's changing the way operators make drilling and completions decisions. So we'll talk about how PrePad's platform shifts the focus from just time and cost to real value creation, and how combining PrePad's lifecycle optimization with Colbor's timeline contextualized data helps operator make faster, smarter choices across the entire well lifecycle. If you ever wonder how data translate into better economics, lower emission, and stronger returns, this episode's for you. So Sean, thanks for joining the podcast first.
Thanks for
having me. Really appreciate that. So, I mean, I think first we'll kind of give the floor to you for 5-10 minutes to talk to us about PrePad, a bit of the history, and maybe even start at your days at Shell and kind of how this company came about.
Cool. Well, thank you. So a little bit about me, about the company, and then how I even got into energy tech is a interesting journey. So originally from Winnipeg, Manitoba, so center of Canada there. And background mechanical engineering, actually specialized in aerospace of all things, and did internships in aerospace. And Shell came to my campus and said they were recruiting. So I thought, you know what, I'll give Calgary a chance, way cooler city. And I mean, from my hometown to Calgary is a new experience. So, and then I spent 12 years at Shell, and all my time at Shell, I didn't look back after that internship. Again, cooler city, and they were paying me a lot more money to come out there. So it was an easy decision for me to like understand more about this energy industry. And if I didn't like it, I could always move back home. So over the course of those 12 years at Shell, I got to do everything from like kind of boots on the ground, well site supervisor during your kind of early days, getting to see the machinery, feel the horsepower on site, individual contributor, kind of like doing engineering programs, executing operations, then moved into supply chain, the commercial side, and then got to manage a team of engineers at the end before I left to start PrePad with my co-founder. And the last role before I left was kind of the completions engineering team lead. So I had a bunch of engineers that would work in Canada's assets, so the Montney, the Duvernay, some of Shell's legacy assets as well, and got a really good wealth of knowledge and kind of joined at the really exciting time for shales and unconventionals, which is 100% of our business now. And also had some like entrepreneurial fire in my belly and passion to go do something. I just didn't know what it was. And I never thought it was going to be a software company in a million years, like especially like very mechanically inclined. I thought it'd be some sort of a physical tool. And then now kind of pivoting into the energy tech has been a really cool journey. And PrePad really started though at Shell. We were just trying to solve a problem, and that's what PrePad is still doing. It's solving problems. But because I felt, and we looked back, and it's obvious there was an underserved part of kind of the whole shale development process. And we talked about it a little bit too before jumping into this podcast. And so what we created at Shell was a way to make our lives easier and not fully rely on some person's uber sophisticated spreadsheet that sometimes a little bit buggy to generate like cost and time estimates as one scenario for it. It's like, okay, well, if we can do that really, really quickly, then I can focus on things that matter more with my job, and we can optimize differently. If we make it based on real physical constraints, I'm going to be able to trust this thing better, and it's going to not be as put together and piecemeal as my spreadsheet is, because it has no first principles physics in there, you know?
Yeah, exactly. That doesn't have it doesn't jive all the vectors of the complexity together, right?
Yeah, 100%. And then though, if you're actually trying to optimize for the business, and at Shell, we were trying to optimize certain assets for like maximizing 2-year free cash flow, and other areas were longer term value drivers. Then it does get away from just lowering your cost, because sometimes spending more money to have a more productive well is the best trade-off for whatever financial value driver you're trying to optimize. So we had created this, like, let's call it the precursor to PrePad at Shell. And when Shell started getting into the unconventionals business, selling their Permian asset, sold some assets in Canada as well, the writing was on the wall that this solution that we created internally wasn't really going to get supported, and it clearly wasn't going to go outside Shell and serve the wider industry. So that's where I raised my hand to take a voluntary leave, and with Shell's support, was able to transition out nicely. And we didn't take anything from them; we just rebuilt it on the outside with their blessing. And that's really how PrePad got started. And so that was 2022. Really, kind of January was when we got started, and here we are now, 3.5 years later, and it's been a fun journey.
Maybe get into the economic side of what PrePad does. That's very near and dear to my heart, because a lot of the conversation sometimes with operators, like, you know, especially on the operations side, we're really focusing on cost all the time, right? And that's kind of the perception, at least for certain in the industry, that certain companies are just like, you know, free cash flow maximization means absolute cost cutting to the bone, right? And and I love how you guys are looking at that from like the economics engine that you've built around it, because even at Colbor, you know, like the thing that we're trying to do is to be able to move all that data up to a level where you can make some of those optimization decisions, because it's really an optimization problem rather than just a cost-cutting exercise, right? In reality. So maybe speak to that a little bit, and what PrePad does on kind of that economics engine that kind of wraps the whole product that you have.
Yeah, I'll use a real world example because it's just easier to talk about that way. So we were trying to optimize our well delivery in the Duvernay at Shell. And we have some levers that you can play with in the completion side, and a lot more degrees of freedom than you do on the drilling side. And with what kind of how this rolls into your question there is, well, we could go faster and reduce cost for the well and really not jeopardize any production because it's not going to affect what's going on downhole. But if you start playing with levers like, well, I want to reduce a little bit of sand because that lowers my costs. And that's awesome because I want to lower my costs as a completion engineer. But I know that now I'm risking production. Well, what about water? If I'm still putting the 2 tons per meter, 2,000 pounds per foot, for our American friends listening as well, that's not the translation though between those two. So let's say I want to reduce some water, but I'm still putting the sand in there. Well, now I've reduced cost and I've given you the same well. I put the same amount of sand in there, but you are risking production, most likely, if you're taking out water. And my group, my team, we experienced this even at Shell too, where we started reducing water and like high-fiving because we're delivering low-cost
cheaper
wells.
fracks.
But that obviously ruffles some feathers with the reservoir engineering and the subsurface team, because then they can't give you the confidence that that type curve and that well production is going to be the same. So that's really where we wanted to integrate not only just the cost and time scenario analysis and the fact that you can do like super quick scenario planning on that side of it, well, we wanted to link it up with what's happening on the subsurface side. And that's an area where we don't predict or come up with that. We leverage what the operator already believes and understands, because everybody's got their own in-house teams and they've been doing this. And that's where a lot of the legacy software was characterizing the fields and understanding how much production can come out of the ground.
Yep.
But if it's 10% more production for double the cost, well, it's probably not going to make that economical. So that's really where we tie that in. So where we get started and how people use PrePad is, okay, well, we're simulating the kind of manufacturing operation, helping you do scenario analysis really quickly. And then what we'll do is we'll link it with your understanding of how the well production may change, or show you that, hey, you can save $500,000 doing it this way. And if we pulled in like your base case P50 type curve, we could also then show you, well, how much you need to increase on that type curve, or sorry, how much you'd be willing to lose or gain depending on if you're costing more money for design or if you're saving money. We can look at it that way too. So that's really what we do, is we kind of try to tie in the best understanding and put it in one platform. Because when you don't do it that way, the development planning engineer will, let's say, grab a cost from the drilling engineer, cost and time from the completion engineer, work with the reservoir team to understand the production, kind of put it together, look at it in a bunch of different scenarios, and help steer the business in what's the most valuable, or whatever their financial value drivers of choice are. So we try to do that in one platform now.
Yeah, and also I think one of the key things that you guys are doing is to really try to force a bit of the whole, like the teams from the drilling to the production team and the reservoir team, to kind of look at the problem with kind of the full scope, rather than kind of micro optimizing per section of the well production, like the well creation and production side, right?
Yeah, for sure. Because I mean, the drillers, they want to reduce their costs too, so they'll drill as fast as they possibly can. But a lot of times, I mean, this is well understood. If you have a really crooked well, it's going to make completions more challenging. So drilling might have saved some money, but then completions has to spend more money. And well, they can lower their cost per foot by going as long as they possibly can. But then it gets hard for the completions guys to actually pump the jobs as per program at the toe of that well, and get your wireline, your coiled tubing at the toe of that well. And then the production side too. They're like, well, each incremental foot or meter that you drill isn't going to give you that same amount of production back. Mm-hmm. So we need to also account for like the non-linear effects happening when you go further and further. And that's understood. But when you're doing that piecemeal, it's just more challenging and more time consuming, when we all know that that's what we want to do. So let's try to do that more efficiently in a platform.
Yeah. Would it be fair to say, based on your understanding of the industry, that there's at least a portion of the industry that has sometimes the wrong incentives per business units? Like you said, like where like the drilling guys are just solely focused on speed and cost, right? And at the detriment of the downstream effect that they have.
Mm-hmm. It's hard to say if right or wrong. I would say the only time I would feel confident to say, hey, that's wrong, is if like they're taking shortcuts safety and environmental wise. Let's say they're deliberately under designing something and they can risk human lives in the area. I would say that's wrong. But if somebody is just like, well, for me in my balance sheet, I want to maximize free cash flow, don't care about these wells 10 years from now, even. I'm really cared about the next 5 years. Mm-hmm. And this is how I want to construct and build my wells and manufacture my development campaign. Go for it. You're not wrong. That's your prerogative.
That's true.
And that's what's really interesting about
But at least, you know, when you say something like that, it still means that you have an organization that looks at the full life cycle and makes a decision on the drilling side that makes sense for the full life cycle. I guess what I'm saying is sometimes my perception is that some companies are creating kind of local incentives in each business units that don't really make sense when they're added up together. And I think that's part of the solution that you guys are bringing to the industry, or to people at higher levels, you know, at those organizations that oversee the whole life cycle of the well, and they can create that confidence that, okay, I can now give a set of incentives to my drilling guys that make sense for the completions, for the production, right? Yes. And not just say,
Yeah, in those silos, definitely we can
Right.
we can kind of cut through the maybe noise in the different disciplines and get a better answer for that business unit or company
Holistically.
yes. Yeah.
Maybe get into the importance of the digitization of the industry in being able to do something like PrePad does. Like that's like to obviously Cobalt, we're in the business of data and the completion side. We're kind of always finding new ways that our data can leverage different business units or within the organization. And I think obviously PrePad's product is very data dependent. So maybe get into the importance of having kind of this digitization in our industry continue to move forward to make tools such as PrePad that much more powerful.
I think probably the biggest benefit I see, and one of the themes too, is just like doing more with less. So you're seeing layoffs in the industry, and we have all this data. We have cloud computing, we have AI and stuff like that, where leveraging different technologies like that and the data and a workforce that's retiring and shrinking, that's really where I think we can add a ton of value as the industry that we're supporting isn't going anywhere. And if we don't do things like this, it's just going to make it more expensive and more challenging to keep getting energy out of the ground at a lower and lower cost in the future, which just means that we'll get less of it out of the ground and won't be as prosperous and won't give back to the communities and the people that actually work at these companies too. So that's kind of where doing more with less is the theme for sure in the industry. And we help enable that with the data and the computational power that we can do in the cloud. And you can just do more with less people.
Yeah, and the do more with less is one thing, and I always get examples from in biotech, for example, and the biotech is one, but like more. I think in the last 20 years, like we've gotten really good at optimizing businesses or industries that are kind of digital first, right? Think of advertisement, right? Advertisement, it's like, Google came in and then, you have all the clicks. And so you can kind of have a digital picture of the whole advertisement landscape. And then you can do all sorts of powerful things with computers now, because like the whole industry is basically in a digital format. So then when you talk about AI or whatnot, like you can use all those tools to improve and move to the next level. And in biotech, for example, they started to also kind of go down that road where now they find ways to digitize their experiments, and now they can move it to the cloud and run a bunch of experiments on the digital format of their experiments, right? And to me, that's the next level for oil and gas or any other kind of, let's say, atoms first industry, right? That you have to find a way to digitize those atoms in a way that let you leverage the tools of the 21st century. And I think that's the transformation we're seeing in oil and gas is very similar, where now if I can have a very crisp picture of my fracks in a digital format, now when it comes to doing simulations or looking back at, we thought that doing this would increase our production, but actually didn't. So now we know this type of sand is not having an impact. So paying, like we've went through this, right? With operators recently, the last 5-10 years, right? We're at some point we're trucking sand from, I don't know, North Dakota down to Texas because it was the special sauce sand.
The Wisconsin sand.
The Wisconsin sand.
White.
All right, that's right. And only to find out that, but because we had the digital tool to really understand like how much we're putting away, how much water we're like, so we can create like an actual scientific way to look at our wells, right, and be able to look back. That allows, I think, like, tools like yours to be like, okay, now we can factor that in the calculation and how that has an impact on the type curve if I do this and all that jazz. So that's the example that I use to kind of when I talk about digitization of our industry and how important it is. That's kind of one of the examples I use, and our industry is probably further behind still than a lot of others. But, it's true for every, let's say, atom-based companies, like the companies that don't work just in the digital world, they work in the physical world. We're all struggling through this right now. Still at the quarter into the century, but with the advent of tools like the new machine learning models that we have and stuff like that, I think like it's really pushing us to realize that, okay, having a digital format of my operations, right,
It's beneficial.
is or it becomes even like a must have, because like now, are you locking yourself out of leveraging all the new tooling from technology by just staying analog about everything you're doing? There's certainly risks that you're going to be non-competitive over the long term if that's going to be your MO, right?
The example I like, because where you're going with this is one that I often used to even start talking about PrePad about lots of times. I'll go there, but then what I see you really talking about is like the manufacturing industry. And because like this table is my unconventional resource play. I got it. We found it. We've characterized it. We understand where some gas versus oily bounds are and things like that. Now I need to go manufacture wells to extract the energy. So it is a manufacturing business. And you think of like a Tesla manufacturing plant, they clearly used some sophisticated software to understand, like, do I want one production like line bay, or do I want two, and like 4 robotic welders? And what are they trying to optimize for? Is it pumping out the cheapest cars or pumping out the most cars? Or maybe it's a blend of the two to maximize their financial value.
Because they have a number they can put around their quality control, because everything is digitized in a way that they understand very well. Because, then it comes service the cars, that'd be digitized too. And then that loops back into the manufacturing process, and it becomes kind of this Kaizen, right?
And that is, they had to do that to remain competitive because their margins were way, way thinner than oil and gas. Oil and gas, like,
there's that.
Making tons of money on the upstream side. And the unconventionals business burnt a lot of investor dollars there in the order of hundreds of billions when they were just growing and not worrying about their cost. And the tide changed a few years back now where they need to deliver returns. So if you want to be the company that's investment grade, delivering returns to your shareholders, even if it's still a very lucrative business and you don't need to be that sophisticated, let's say, to get it out. But once the tier 1 acreage goes away, then you're in the tier 2, and you have a demanding shareholder base, you're going to need to use these tools to optimize your manufacturing business.
Especially
that's the industry that we're
especially at the level of pricing that we have on WTI, right? Over the last decade. Well, it's close to the decade since 2015. I mean, it's not like there's a lot of space there to be sloppy and keeping those return. And then you look at the market valuation on a company like Tesla and a company like Ford, and you clearly see where the investors are putting their chips in terms of what model they believe is going to be long-term sustainable and growing. And I think that's becoming a thing in the oil and gas industry as well, is that you'll have to show that capability over the next years so that investors continue to believe that you'll have the expertise and the technology to go to those tier 2, tier 3s and continue to do those returns, to make those returns happen for investors at potentially fairly depressed prices even.
I was curious actually about if you had any examples of like what kind of data you're bringing in, and if there's any like examples of things that we were working with a client, they found kind of surprising that your software pointed out, and shifts in maybe how they're planning it or how they're thinking of their free cash flow that they didn't consider before working with you guys.
Yeah. So some of the data that we bring in, and this will be synergistic to some of the stuff that you guys are tracking. So in our kind of niche of the space where we're providing a solution for, most of the incumbents is in-house workflows and spreadsheets and things like that. So a lot of the inputs would be, and I did this when I was an engineer too. I'm like, okay, well, how many fracks per day, or how many pumping hours do I want per day, or how many stages per day? And that would be an input. And then when we kind of teach them how to use PrePad early on, we say, well, we don't actually have that as an input. what do you mean? Like that's the input I have. I pump in 20 hours a day, or I pump in fracks per day. We're like, no, we're actually inputting like base level data of like how fast are you running in a hole with your wireline? How fast are you pulling out of the hole with your wireline? What are your average transition times for like no maintenance on the critical path? And then what's your average maintenance cycles with this frack provider? Is it 60 minutes every 10 million pounds of sand pumped and stuff like that? So that opens their eyes, and it's surprising to them, because lots of times when you start deviating from just, let's say, drilling, completing the same recipe, those inputs that you had of 22 hours of pumping or 19 hours of pumping or X amount of stages, they start to go away and they don't hold true anymore, because you've added different constraints or different bottlenecks, or put something back on the critical path that you can't detect on the planning side. And that's where you guys come in on the actual monitoring side, and you see what's actually happening. So a lot of the ahas, even when people first get into working with PrePad, is the granularity of the inputs that we have. And again, you don't need to set those every single time, but to have that simulation platform need that type of information gives you way more robust and accurate answers coming out the back end. And again, if you were only doing the same thing forever, you wouldn't need that, but people aren't doing the same thing forever. And when you change from a tier 1 to a tier 2 to a $80 oil price to a 60, you often want to tweak your design. And so yeah, that's probably one of the bigger things that we notice.
Interesting.
Do you want to do a little clip for the, go back to what we do at Coolbore, so that we can kind of slide this in?
Yeah, for our audience listening, most of you hopefully have heard a few and know kind of what SmartPAD is, but anybody new listening in, so we're with Coolbore. Alex, our CTO, I'm Derek Mathewson, Director of Product here. And at Coolbore, we have our kind of flagship product, SmartPAD, which is digitizing the wellheads and capturing all the data on completions. And so we go out to the frack sites, we're grabbing fracks data, wirelines, pump downs, anything else you want. We got noise and weather, sand silos, temperature, and we bring it all into a single platform, so that central place on location. We stream it up to the cloud, so we can enable ROCs, so remote operation centers are calling fracks real time from Houston within our system, because we can provide them that sub 2 second latency, and with that a 99% uptime, so they can trust our system to call those fracks, bring all that data together, and then provide it in lots of interesting ways, whether they need it through a data warehouse or API, bringing it into their analytics team so they can start breaking down that data and understanding what their systems are. And so that's where there's a great synergy between us, because we're that monitoring side, we bring in that data. We automate a lot of that capturing of that time log, so you're not having to send your engineers or your interns to try and capture these things. We automate all those things off of the sensors and off the valves that we're monitoring. And then we can plug all that right into PrePad, and I think we can come up with a lot of interesting.
Hey, Melina, can you bring up the slide that we had earlier regarding manufacturing reservoir real time and post analysis? Because I thought that's a slide from Sean, and I really, really like it, because even in many investor presentation that I've seen, I haven't seen it broken down this way, and this is a way that makes a lot of sense to me. And so you see, Leo, like that PrePad Coolbore really lives on the manufacturing side. Like there's a lot of people that are doing a lot of stuff on reservoir, trying to understand what's happening kind of on the formation level. And really PrePad Coolbore are more focused on like the process of the completions, but in kind of like different aspects of things, where PrePad, like, the names kind of speaks for itself, right? It's before you go into your fracking, so you can simulate how you want to go about it. And Coolbore, on the other end, is not really into that. It's more on in real time while the operation's going, be able to support people that are running the operation. Like you said, like we have an ROC, sub 2 seconds, all that good jazz. It's really kind of like focus on operations, but also providing that digital picture of a frack, right? So that there's really kind of a two-way synergy between Coolbore and PrePad, where then Coolbore can insert kind of PrePad's data into it to support people running the operation, so that they're well aware of how this is supposed to happen based on what, for that whole, again, we talk about the life cycle,
the detailed plan,
the detailed plan, so that we can also put it in their face in during the operations, and also we capture what actually happened, and based on the input from the plan, and we can move that back into PrePad so that the next simulations for the next well gets more and more refined. So like that's the way that our tools kind of have a very complementary nature. I don't know if you guys had anything to add on that, but I wanted to point that out.
I know we've seen cases where they might have plug slipping, or they're not seeing the well treating the way they want it to, but they just kind of stick to it because they're like, get the sand in the hole and let's move on to the next stage. But I think as our softwares mature, as this industry matures, I think we could see a future where you're changing plans per stage, which some operators are doing, but it's very difficult to do, right? And I think kind of falls onto that, maybe that individual contributor of like, he's holding the bag if he messes up that change. Where I think having tooling like ours could really help empower those people to feel more confident in trying to make those decisions.
And it's when things go wrong, it's always like 4 a.m. on a Saturday. And these last two stages were super tight, and should we drop some sand we're trying to put in there? Should we add more perforations? And it's like, well, it's 4 a.m. on a Saturday. And the thing is, it's like, well, I don't know if I make that change, what is the impact going to be to just the cost and time? But we went through this whole process and optimized this design because it hit the hurdle rates we needed for IRR, and it was the one that maximized the most 2-year free cash flow, let's say. If I make this change, like, am I jeopardizing that? Am I not jeopardizing that? And that's where, you could do a quick simulation in PrePad and understand, what's going to be the impact? Call, let's say, the boss or somebody else and get the blessing to go forward with it and just have the information.
Yeah, and the ability to move that real-time data back to you guys so that you can kind of have the data required to rerun that simulation in real time. I think like that's the ultimate, that's kind of the wet dream.
Yeah, exactly.
Right?
Yeah, that would be, and obviously because we're not just dreamers, and you guys have built something pretty amazing, and I think we have too, you realize what it takes to get there. Real time. So it's like, let's do like pseudo real time and then understand how much work and effort to get to the real time, and again, trade-offs of,
and also it's also is this juice worth the squeeze a lot of time, right?
For sure. Yeah, maybe it's not right.
And maybe like moving that data into your next simulation for the next job is optimal.
Good enough. And
right?
after just the stage, like, I don't need to, the good thing about completions too, it's like, well, maybe some fracks are 30 minutes, some of them are 3 hours. You're probably not going to change anything mid-frac.
Yeah.
Maybe you will, but on the next stage, it's like, okay. And that doesn't require as much of an exhaustive, you guys know the bits and bytes flying around. And do I really need it like within 2 seconds, or am I cool to get it 45 minutes before the stage is done?
Yes.
Yeah. And that, from the people building the connections, is a lot easier. Probably.
Yes.
Yeah, absolutely.
Yeah. Like it's a very different problem than, let's say, we have a customer working on, like, they're trying to detect screen outs and stuff like that, where our real-time data becomes really, really critical. For you guys, it's less of that, but having a completions data set that's easy to consume and digest and understand, right? And that also is always the same, whoever is the frack company, whoever is the like whatever, right? That's agnosticism we find is very powerful for customers, but also partners and other vendors that build on top of, or can build on top of the data set that we provide. So in the news, again, more and more news about LNG. I mean, it's not going away. Like the CapEx spend in AI data centers in North America, so both in US and Canada, like we even see it a ton here in Alberta specifically, is crazy. Like like these companies have had these giant cash position on their balance sheet for as long as I can remember, kind of tracking them over the last 10 years, like Meta, Google, all these
Mag 7,
the Mag 7 plays, and now like they're like taking it out like hand over fist to invest into those data centers. Some of the I don't know if it's in this article particularly, but I know that on something that I've seen is that I think already in North America it's like closing in on like 5 to 10% of the grid consumption is going to those data centers.
Wow.
It's, maybe don't quote me on that. Maybe I'll just need to cut that. But like it's already ramping up, and if you look at the backlog of data centers that are in the pipeline, there's a lot of worries about the grid, because we really haven't done tons of our grid. Like if you look at energy consumption in North America, I think it's been flat for close to 40 years
For electricity?
Yeah. Right. And now this is really kind of an inflection point in our overall in energy or electricity consumption, specifically in North America. Right. This is where like a lot of the plays are happening. And I mean, it makes sense. It's close to the resource, because we know, and everyone agrees, and even the Greens agree that, there's no other way to really power that today outside of natural gas.
Yeah, small modular reactors, but they're not here till the 2030s.
Yeah, and they have other problems.
And they have So
they have other problems. Like we've I think it was.
And there's a race though too between, like you said, in North America. It's like we were hearing about it and seeing it, because we're also, especially the U.S. is trying to become the dominant player and win this
race.
Arms race for AI.
And the fastest way to make sure that you secure your position today is to power it with natural gas, because that's so plentiful on the continent.
Which is awesome for
our industry.
Yeah. And also just building on some of that too, when you mentioned the numbers recently, I was at a conference, and the governor of Texas and the premier of Alberta were there talking, and in the U.S. There was this 11 gigawatt data center that they got approval for, and they're going forward with it. And our premier talked about the contrast of Alberta's full grid is 14 gigawatts. And,
yeah, there you go.
And that is insane. And you can't just plug that thing in.
No.
And because that needs the 5 nines of uptime, 99.999. So you need to have, and you can't think that you can power it with the current type of renewables out there, because you need that exact amount of power as the backup ready to go as well. So it's let's just use gas. This makes sense.
And we're seeing even Google getting into energy. Now, where they're trying to figure out, well, maybe we need to vertically integrate all this, because we can't just say we'll just expand the grid. We'll have to have our own dedicated power source in order to ensure that 5-9 sort of uptime there. Do you have anything on that?
No. Sean took my point. I was like, I'm coming in with this 14 gigawatts point. And
Shoot, you had that one.
I loaded in my head. Yeah, that was all good though.
Stealing your thunder.
Well, and I mean, that makes sense when we were talking about this, getting into the 5-10% of total energy consumption. If you think one data center in Texas is going to be 2/3 of Alberta's total energy consumption.
It's a lot.
It's a scale that's wild.
Yeah, and that's only one, right? There's XAI, Stargate. They're all building their own data centers.
Yeah, a lot of it in Texas, if I'm not mistaken, right? Because they're trying to get it pretty close to the resource. Same as what they're doing in northern Alberta, I guess, here, where there's some very large data center plays that are starting to build up in the Grand Prairie area.
Close to the source, yeah.
Close to the source.
There is that fairway in the U.S. though too, West Virginia or somewhere. Was that where it is? I can't remember where it is. No.
Well, I mean that's another where all the, I think the article here was talking about EQT. And it's more about LNG exports in that case. I mean, there's the data center play is one thing, but on the LNG side, there's still the geopolitical environment that we live in, kind of 4 years into the war in Eastern Europe, where the Europeans are still consuming a lot of Russian gas today. And, they're kind of foreseeing a potential conflict with Russia directly, and what that would mean for their industrial base and for just their lifestyle and their defense, and really, we're even seeing Canada now exporting LNG, so it's got to be pretty bad.
It's unloading. It's unloading the first tanker as we speak. I think
in Korea,
it was circling around Asia somewhere.
Yeah,
and they're gonna unload the first shipment, which is pretty cool. It's crazy how long that took, because I started at Shell and they were
talking about it.
Well, they were working on that project.
Yeah.
And now
the Americans have gone super fast, like in the Gulf, for their project, like the Gulf of Mexico right now. And there's at least a dozen projects that are still underway for LNG exports in that area. And so that's going to be a new market essentially for North American gas. And I don't think the Europeans are ever going back to relying on Russia. Hopefully not. And so that's a good segue into the practices of our energy companies in North America and how they go about producing that resource. And so maybe I'll hand it over to you, Derek, to talk about that article around a Chevron going into triple fracking in the Permian into 2025, 2026.
Yeah, I think this is important to think, like, the big push here is lowering that cost per lateral foot. How do we get it out in the cheapest way possible? Mm-hmm. And I think there's a lot of, especially surface level optimizations that we're seeing in the industry. So, like, kind of getting to this, but also, like, we're seeing continuous pumping now with switching valves without cutting rate, U-shaped wells, longer laterals, but also now with simul-fracking expanding and becoming really a standard practice. I think we see almost all of the operators we work with doing some sort of simul-fracking, whether that's with e-fleets or multiple total frack units. So they got 18 pumps and 18 pumps, or fracking 2 wells at the same time with one set of pumps. Mm-hmm. And now we're seeing like trimul-fracks. I've heard rumors about quad fracks where we haven't worked on one yet, but I've heard rumors of that. So it's pretty exciting time in the industry and what they're able to unlock. I think in the article they say, what was the savings? I don't want to quote it wrong.
Oh, completions time by 25%.
Yeah, there it is.
Yeah.
25% cost per well down by 12%, but it requires 60% more water and sand per day. I think one of the questions that was in there is also like how much it's clearly the Permian. The Permian is so well, the infrastructure in the Permian kind of allows for a lot of this. Mm-hmm. It'd be interesting to see for the other places in North America how they can keep up to that type of, because if you talk about Appalachia, there's actually a lot of gas there, but the infrastructure and the geological or geographical challenges are very, very different to allow you to move that amount of water and that amount of sand in order to keep like the operations going 24/7 and getting to that 23 hours of pumping per day. Yeah. On a simul frac, even if it's 3 or 4 wells, like Absolutely. It started to create very different challenges depending on the basin that you're talking about. So
and those are already astronomical numbers in the zipper frac.
Yeah, right? Exactly.
And then to increase that by 60%, like most people don't comprehend the logistics and how much material you're really moving to just satisfy what we were doing with zipper fracking, let alone simul fracking 2 wells, 3 wells, or 4 wells at the same time. Yeah. And when you talk about the different regions, like Canada, for example, we get a lot of our water to frack with from, like, also there's freshwater sources. There is a lot of recycled water as well, but in certain areas, they don't have the infrastructure built for this recycled fluid, so they're taking it from runoff during the spring breakup and after the winter and the thaw, and you just can't take that in September or in October. It's just not. It's just not there. To do. There's the bottleneck, or it would just cost you so much that it wouldn't be a slam dunk like it is in the Permian.
I saw. I think it was the JBT article from last year's conference. They were talking about, I forget who was saying it, but talking about that in the Permian, they're now pumping. They're producing 25 million barrels of produced water per day.
Yeah,
they're like,
it's insane.
our industry has never dealt with this before. Like, and they also recognize now within the industry that like they're pumping it into like old reservoirs and things like this, and that has can produce some seismic activity. So they have to monitor how much they're pumping into these wells. So it's finding these optimizations. You find new problems too. You have to try and manage here.
For sure. And in the talking about like with these optimizations come some opportunities to change your business and adapt to being able to cater to different manufacturing methods like simultaneous fracking. What did you guys have to do to like obviously you're tracking things and you got things mapped and you know what a zipper frac looks like and sweet. So we built it around this, and then people start fracking 2 wells, 3 wells at the same time. What, how did that throw you for a loop, or how did you deal with that?
Derek actually is the one that worked through all these things. So I'll leave it. It's his baby. I'll leave him with that one.
I mean, there's a few challenges. One of them, like where we took a misstep, where we first thought was, okay, they break them down by well banks. So, okay, simple enough. We break down by well bank. You have group bank A, group bank B. We can set up our analytics to look at per well bank. And then we quickly realize, okay, they jump well banks. The wells, depending on how their frac set up, so some will do where both frac, if they have 2 full frac fleets out there, each one will be connected to every well. And then they can jump either way. And we can kind of tell based off where valves are going, or they'll run a single mono line from each. So it'll be like a mono line around all the wells. And so any of them can frac any well, and you can't follow unless you put a valve sensor on every single valve out there, which is just too cost prohibitive to do. That it's like, okay, well, we can't really figure out where they're going, which frac unit is going to which one. But in the simplest way, we now monitor the frac service. So we monitor frac A and then frac B, and then we can just build our analytics from there. So we basically just duplicate kind of everything that we calculate, and we just do it like per frac service out there. So in that way, it's built, it really can expand to, trimal frac. We shouldn't really see any. We just have a third frac service unit, and away we go. We can just look at pumping hours, and we just relate everything back to each frac service unit.
Yeah, because
simultaneously fracking 4 wells at the same time doesn't keep you up at night. Like it's an easy thing to do now.
Yeah, because when we went to dual frac, right, one of the things that we sat down and we were like, these motherfuckers are going to do 3 or 10. And so as we develop this solution, let's imagine kind of a craziest.
2 is not the limit. It's probably going to be 3.
It's probably going to be, So what if they were to frac 25 wells at the same time? Like, would this model work? Because like our goal is always to be able to say, if I have a pump that I'm tracking on this pad, I need to be able to tie it to a well at any given time during the day and which well it was engaging against, right?
Yeah.
So we have to tie that whole thing so that when we deliver the contextualized data, if you're doing a pump analysis or whatever type of analysis that you have to do, that the data set is consistent to give you these answers, as there's no kind of hole in the data model. So that's where like that was a challenge for us, is to be able to always be able to connect all those dots for all the sensors that we're monitoring on pad to tie them exactly to the well they were engaged in, or the wells they were engaged in that case, right? Because that's kind of what the problem was before. It was like, okay, one pump can tie to one well, right? It's a 1-to-1, right? But all of a sudden, okay, no, it's not a 1-to-1, it's a 1-to-n, right?
Yeah, and one pumping bank is pumping only in one well. Versus n
number of wells, right? And so I had to tweak our data model to match that, and also we have customers that rely on our current data models. So how do we make sure that it's backward compatible with our old data model, so that like all the integration that we've done with customers downstream into their analytics team is not going to get broken by our breaking change in our data model, because we need to now consider the fact that it's a 1-to-n relationship.
Right.
And so it's all sorts of like very nerdy. And then it was Cold War is a software company, right? That's what it goes back to, because our really hard problems is very different than you guys' very hard problems, in the sense that you guys' very hard problems are much more tied to the oil and gas space, right? And the mechanics of those things. That's where like they all complexities and I guess the value that you've built into PrePad, I think, is a lot about that kind of oil and gas knowledge that's kind of built in the tool, right?
And then there is the physical, like the process simulation aspect, because we are a process simulation platform for completion. So we need to be thoughtful with this as well, how we would hit the simulate button in PrePad and it knows the zipper frac, but now I want it to do a simul-frac.
Yeah, so maybe talk about you guys' challenge with the simul-fracs, moving over to that.
Well, it was, and again, I was not as intimately involved as you would have been on the cold bore side with it, because it's just not my domain to do the code and the algorithm, the programming. But knowing what we wanted to get as the output and realizing that we had some gaps to actually do it successfully, and understanding when you talked about like the industry and the domain expertise, it's like, we needed to also put certain rules and logic in there too, right? Like if you have a super high frac gradient and a low frac gradient, and you want to pump these both at 80 barrels a minute, well, how do we do that? And how does PrePad know what the pressure should be? And if you also had a Triple-Frac operation and you want our simulation algorithm to actually give you what you'd expect, there was a lot of nuance in how we can get to that accuracy and have it predict what you would expect to see in the field.
So I guess you faced a similar challenge where the way that you originally thought about the simulation or the simulator didn't really comply well with this kind of multi-frac scenarios.
Yeah. Because we knew coming out of the gate, we didn't need that to be perfect.
Yeah.
But very, very soon we needed it to be
functional.
Very, functional, but really accurate, like within 1% of what you'd expect for your cycle time and your costs. So it was, we knew of this. It just wasn't something that we built fully into at the end number of well. But then, because we were getting a lot of pull from our US clients, we quickly adapted and built that into the software as well. So then now in Canada, it was a little bit slower to adopt that. It's just ready to rock and roll if they want to evaluate things like that. So then the ability to just test scenarios in seconds and understand what the outcomes are. Now you can use PrePad. If you're a Canadian operator and haven't done simul-frac before, you're like, well, what's the benefit for me?
Yeah.
Can I even do it? And that's what's pretty cool is it scales, and just like your platform gets better and better and can now serve a wider market. Well, because we're working with big clients in the US, they pulled us into the depths of the simul-frac very soon. So it's been a cool journey on that one too.
I have a nerdy question that always I like to ask, because you're essentially running a software company.
Yeah.
You're not a software guy.
Yeah, no. I'm not.
From your
old mechanical aerospace, working in Shell as a completion engineer.
How's that? Because I'm kind of the opposite of you, where I'm a software guy that was kind of parachuted into the oil and gas space. Mm-hmm. So my challenges are the opposite of yours, essentially.
Yeah.
So I just wanted to maybe ask you, like, kind of like, what is the biggest challenge, like running a software company as a kind of non-technical software person?
Yeah, and it was funny that you say the technical thing though too, because people would ask like, "Are you a technical founder?" And I used to say, "Yeah." And they're like, "Oh, okay. Like, well, what languages and things like that?" I was like, I mean, like, no, I'm an engineer, and I worked in the domain doing all this technical stuff, but like, I quickly realized if you're running a software company, I am not a technical.
The Silicon Valley way of looking at things founder. Certainly is that.
So how did I find that? I found that challenging and extremely valuable at the same time. Extremely valuable because I can speak my client's language. I've sat in the chair. I've had engineers report to me. I've been an interview contributor. I've been out in the field and I've done what they've done, and I've worked with the problem. So that was extremely helpful, and it continues to be extremely helpful with empathizing and building the right software product for users like myself and my peers that I worked with over the course of over a decade. The really challenging part was, well, I don't know how to build a software company. And so that's where surrounding myself with people who had been there and done that, leveraging my network, and mainly it's about the team around me too. Like,
maybe
my
talk about your co-founder a little bit. I really like him. If you have a chance to go have a beer with him, I know I did.
It's a great guy.
Awesome guy.
So Brandon, my co-founder, he filled, like, we complement each other very well. And he came from, he can do a lot of things, but in terms of like the algorithm, gnarly computational stuff, and really being able to build a product, was an exceptional complement to what I didn't know how to do. But then we also brought a CTO in, which was Cole.
Yeah.
And that is where, like, he has a geoscience background, but then quickly went into software and did exceptionally well at companies that are familiar in our space and still in existence. And that really kind of like rounded us out, where we had a enterprise software guy. We had Brandon that could do amazing things with what we needed, this simulation platform and building a product here. And then you had me, who has used tools like this to help me in my engineering career, whether it was like SolidWorks as a mechanical engineer, or whether it was empathizing with the gnarly spreadsheet world of working in an oil and gas company and wanting to find a better solution. So it's an interesting question, because challenge, opportunity, and then make sure you fill the gaps with the right people.
Knowing you guys a little bit, like I find that your kind of exec team is really well rounded, actually. Because like Brandon, like, we were talking about that. He was like, because Brandon's not a software guy either, but he kind of is, right? Yeah. And but he could build a prototype, and that's like, my role at Colbor is very similar, or has been very similar, at least in the past, as to what Brandon is doing, where I could create a prototype that would be very comprehensible. That then it's like, and then I had like Cooper, who was like kind of my right hand on the software side. He's a much better software engineer than I am, and I can be like, this is what I want, and it's in technical terms, and it's code, and it's like, just make this work better. Yeah. Right. And that's kind of what Brandon did, right? He's like, he had this thing that he built, and it's like, I don't know if it scales. I don't know if it's, all of those kind of classic software engineering problems, but then like but it's hard for a pure software person to just start from scratch either. Right. If they don't know the domain at all. For sure. Really challenging. And that's where, I hope Cole sees this part, and if it makes in the podcast, is like, I remember when Brandon and I like came and met Cole, we're like, hey Cole, we just need you to take this and like put it on the cloud. Yeah. And he's like, okay. What do you actually want? Yeah. But he had something, right? We did. And he had something to work with, of course. But like knowing how to build enterprise grade software for the clients that we work for isn't trivial, and it's then you're talking about security, you're talking about like all these things, right? So it's an exceptional team is how we did it. Yeah, you guys we're still doing it. You guys are doing awesome. Cole's question there. Wait, so what do you actually want? Wait, put it in the cloud. Like I just told you. Right? What else do you need? That's the whole gist of it. That's why we hired you. Really appreciate everyone listening. Again, like every time you can, give us a like, comment, whatnot. Sean, maybe in the outro, maybe just give people a chance, or give people a place where they can find you. LinkedIn's the easiest. PrePad, and if you want to go to our website, prepad.io is how you get there. And we're active on LinkedIn. Like, comment, message me directly, and you'll get a hold of us. All right, that was the Nerdin Out podcast. Appreciate you guys giving me the opportunity to be here. Man. Thanks for coming. Fun. Yeah. Data in hand. We rock the bytes and we'll take a stand. Calculators flashing like a disco ball. Cold board tech, hey, we answer the call.